Good evening. This is your special chance to learn how to properly run Cut-Rite. We have imported a genius from North Carolina to teach us how to do it. So I'm going to turn this over to Sam, the man, the optimizing guy, and he's going to go through this. He'll try to tell you what buttons he's hitting, and the idea is to be prepared for when somebody from Stiles calls you and says, let's do a test.
Okay, guys, in the context of you are collecting data from a customer to do either a sales presentation or possibly a machine analysis, we have loaded up a few part templates into your Cut-Rite V10 inch default import folder. In there, we have distributed a template we had sent to a customer, had the customer populate this information for us with his own cutting list, which we represent with what we collected being from customer 123. This is his cutting data. In this list, the information fields other than 2, 3, and 4 are not required, but they are desirable and will give you a nicer presentation in your software by having information such as job description, product, edging information, and what have you. But if you're running a machine study, you will definitely need a material code, a length of the part, width of the part, or a quantity. In this example, we're working in an inch folder, so we're working with inch data, and it works just the same if you were working with metric. You would work in the metric default data. In our example, we are working with the customer's material code, which does not exist in our Cut-Rite board library, and you'll see how you'll be able to easily duplicate or create this material code for your own optimization. This is designed for a relatively simple part list. It has just a few codes. As you'll see, it's quite easy to duplicate and create this information. If you have a much more diverse list of material codes, there is a different option that we would use, which would be the board list import settings. Is there a separate template to collect board information where you have a variety of different material codes and a variety of different sheet stock sizes? Using the power of Excel should expedite creating that board data for you. Okay, so when we're done with this part list, we will save it into File, Save As, and we're going to save it into the C:\V10 inch default import folder. This is where this folder is defaulted to look for the parts list that we're importing. Okay. So now we're going to start your Cut-Rite using your V10 icon, and it will open to the last user profile that you happen to be in. If you had previously done a Wood CAD/CAM demo, you may be in a Wood CAD/CAM user directory. So we can verify this by going to File, User Profiles, and in User Profiles, we're going to verify that we're in default inch, or if we weren't in default inch, we're going to select that and select OK. This will take us into a user profile that is set up specifically for what we're wanting to do as far as importing part list. From here, there are several different ways to import a part list. There's an option to go through the File menu, import part list from this menu, but the more simple approach would be to go through this shortcut menu and go to Import Parts. So this is already set up. You will see the part list that we had saved from the customer into this folder, and by double-clicking this file, Cut-Rite will read the template that we saved. In this case, it was already imported before, so we have the part list as we imported. This part list, as we spoke of earlier, does not have a board list entry in the board library. So what we're going to do is we're going to go to from part list to our board list. It will recognize that we do not have this, and it will give us the material code sort of pre-set up, so it'll be a little bit easier for me to create a board list on the fly. In this example, we're going to do a 4x8 by creating a board code using the material code by adding the sheet stock size. So when we see this in other screens in the software, we'll be able to easily identify what material and what size of that material we're working with. Now, our customer has confirmed to us that when his 4x8 is a 49 by 97, the thickness we can read from the material code is 3/4, so 0.75. The information box is not required. It would be nice to have a quantity. If you use 5 nines, you have, assuming basically infinite quantity of sheet goods. And a cost is very important to cut-rite optimizing, particularly the professional optimizer, where it does a comparison of the cost of material per square foot against the cost of running the machine per hour. So highly recommend you always have a cost in your an entry in your cost field. In an example where I don't have if the customer did not share with me the cost of his material per square foot, in inch you can easily assume and get a very valid results by just using a cost per that match the thickness. In this example, we're going to go with 75 cents per square foot. And if this were a grain material, I would change this to yes, but white is obviously non-grain, so we're going to leave it at no. Okay, so we also want to add and give the optimizer a second choice, as that this customer frequently cuts from 5x9. We're going to make an entry for that as well. One of the quick shortcuts to navigating in cut-rite is that you can use the space bar to copy from the field directly above you. So let's enter the width in here, 61 by 109. That's what his 5x9s are. And the thickness, by hitting the space bar, will copy from the column above me, space bar again, quantity, and the cost, space bar again copies that. So we're easily duplicate that board list. You could continue to add board lists if you like, but for what we're doing, this will suffice. So when we run through the optimizer, it's going to look at these two sheet stock sizes, and it will give me the best combination of the two different sizes if for the result we're searching for. In this example, we optimize this part list just by itself, and we have a result here. This would be the pattern preview screen and the results that we created. Okay. In this example, what we wanted to do is that you could take these results, working through the batch and summaries, to discuss this result with your prospective software customer and show him information about the breakdown of the parts in this list, the breakdown of the sheets that we used, and the breakdown of each pattern that created and how it compared with the number of rip cuts, cross cuts, and what have you. Okay, so that would work with an individual customer. However, if we imported this part list for the purpose of studying two different builds of home ag panel dividing saws, we're going to create what's called a batch. So we're going to escape from here, and we're going to go in and create a batch, which is this part list optimized with 3 different builds of saw. So first thing to do is go to your menu, under review, select batch optimization. Batch optimization, and now we're going to start a new batch and give this a name. So let's call this machine study. And we're going to use the customer's name as a description so that we can, our reports will be more informative about what we're working with. So the customer's list, we just named it generically. Customer 1, 2, 3. Okay. Now, in order to work with this, we're going to take the cut list. We're going to select the part list that we imported. And now we're going to identify the machines that we're processing. Is we're going to take either, you can use a sequential run number, or you can go in here and name the run, and this will be more informative if we're going to name this, because we're going to do a study on an HPP 250 model machine. We're going to use, that being a front load machine, we're going to use our front load optimizing parameters, and we're going to select our HPP 250 US edition saw parameters so that we're optimizing for that build of saw. Okay, now we're going to create a second line in the batch summary. We're going to use the same part list again. We're going to use this for an HPP 300. 300 is a similar build machine, but with a taller cut height. And we're going to set the parameters for HPP 300. Okay. Now we're going to add a third machine. Using the spacebar again, we're copying from the field directly above us. You could use the sequential run number again, but we're, like I said, we're going to have us be able to identify the run more easily when we get to the summaries if we use something that indicates what machine the run indicates what machine it's optimized for. Here we're going to use the HPP 300 power concept machine. In here, we're going to use the same, by hitting the spacebar, we're going to use the same optimizing parameter, and we're going to pick the HPP 300 power concept machine. Okay. When you're here, you'll be able to do some editing. If you needed to edit the parameters in the system, you have an option to going in and tweaking and modifying some of your settings, like what you might be using for trim. You might be looking at the number of open parts. So you can edit this on the fly if you are optimizing this with different settings to improve the yield, or to offer different options for the optimizing solution. Okay. So now we're set. We hit the optimize button. It will optimize these sequentially, and we will get a report that shows us these three results on the same page. Okay. This is our batch summary. It shows us that the first job will take 20 minutes on the HPP 250. It'll take 16 minutes on the HPP 300, which is a similar machine. It just has a taller cutting height. And on the HPP 300, with the same cutting height as the 300, the power concept machine has a second self-articulating clamp that allows us to cut multiple strips at different length increments at the same cutting cycle. So we see it cuts at 12 minutes. We take a look at the patterns by pressing enter, or either going to the management summary. It will break down each one of these optimizations independently. So now we see that the number of head cuts and number of recuts, in this example that we see 20. Since we use the same optimizing parameters, it makes sense that we came up with very similar, if not exactly the same cutting patterns in this optimization. So, and that's what we'll see here is looking at the pattern preview and now the individual pattern programs. As I scroll through the results for the 250, we'll see that we use the identical same cutting pattern solution developed for the 300 and likewise for the HPP 300 power concept. The indication that explains the results for us is that it took longer for the 250 because it had to process another cycle of cutting. The 300 did it in less cycles because it had more book height, but the power concept gave us faster patterns because when it processed the patterns, we see that these strips are being cross-cut together, which is indicated by what we call staples, is that whenever this pattern cycles on the 350 power concept, it will get a trim cut, dividing cut, second dividing cut, third dividing cut, fourth dividing cut, and then a rear trim. As with most and all holes and panel saws, the first strips off produce are the first strips back in. So when the strips are turned to do the cross cutting against the right angle fence, we're going to accumulate these three strips, strip 1, 2, and 3, because they're stapled together, will be cross cut together. The power concept will grasp this part, these two parts, as well as the traditional program fence will be positioning the third strip in the same cross-cut cycle. Once those parts are unloaded, the staples here indicate that strips 4 and 5 will be cross-cut together and produce these parts that you see here. That ends our import. If you have any additional questions, please contact Roger Shaw. Thank you.